Hi, good morning to all. In previous lecture, we discussed about performing an arithmetic or logical operations, means how the operands are transferred to the ALU and how the ALU will perform the operation and how the result is transferred to the destination register. In today's lecture, we are going to discuss about fetching a word from memory, means how we will fetch the data, means how we will fetch the address of the memory and how the content in that address is transferred to the processor internal bus. See, here in this lecture we will learn how the data is transferred from memory and how that data is transferred from memory to the processor internal bus. Okay. In order to fetch a word of information from memory, the processor has to specify the address of the memory location where this information is stored and request a read operation. Okay, so first what the processor has to do, the processor has to specify the address of the memory location where this information is stored and request the read operation. This applies whether the information to be fetched represents an instruction in a program or an operand specified by an instruction. So the processor transfer the required address to the MA or memory address register. Okay. In order to specify the memory location, the processor first it has to send the required address to the memory address register. Okay, whose output is connected to the address lines of the memory bus. Okay, first the processor transfer the required address to MAR. Okay, so the MAR memory address register output is connected to the address line of the memory bus. At the same time, see here, the processor transfer the required address to the MAR memory address register. So the memory address register output is going to be connected to the address line. Okay, address lines of the memory bus. So first the processor transfer the required address to the MAR and whose output is going to be connected to the address lines of the memory bus. At the same time, the processor uses the control lines of the memory bus to indicate that a read operation is needed. Okay, so whenever the processor sends the address to MAR and MAR memory address register will send that address to the address lines of the memory bus. During this process, the processor uses the control lines of the memory bus. Okay, so by using the control lines of the memory bus, it indicates that the read operation is needed. When the requested data are received from the memory, they are stored in MDR register. Okay, so whenever the address is sent to the memory, memory will fetch that address and the data in that address is received from the memory. Okay, so that data is going to be stored in the memory data register where they can be transferred to other register within the processor. Okay, the connections of an MDR register is shown in this figure. See, it has, so MDR register has four control signal. Those are MDR in control signal. So this is the memory data register in control signal, and this is the memory data register out control signal. And the next one is a memory data register in external. Here E represents external to the processor. So these two control signals, MDR in, MDR out, are internal to the processor, and MDR in E and MDR out E. Okay, so these two are external to the processor. In order to differentiate processor internal data register control signal and processor external data register control signals, here we are represented the E. Okay, so MDR register has four signals: data register in, memory data register out. Okay, so the control the connection to the internal bus. So both MDR in and MDR out controls the connection to the internal bus, and MDR in E and MDR out E controls the connections to the external bus. A 3-input multiplexer can be used with the memory bus data line connected to third input. The input is selected when MDR in E is 1. Okay, here we will use a 3-input multiplexer can be used with the memory data line connected to the third input. See, so whenever the MDR in E is high, then the data which is fetched in the memory is transferred from memory bus to the MDR register, and that fetched data is stored in MDR register whenever MDR in is high. Next, a second tri-state gate controlled by MDR out E can be used to connect the output of the flip-flop or the data which is stored in the MDR to the memory bus. Okay, so the two control signals MDR in E and MDR out E are used in order to transfer the data either from memory data bus to the MDR register or from MDR register to the memory bus. MDR in E is enabled whenever the data is transferred from memory to the MDR register. Means the data is going to be stored in the memory data register, and MDR out enable is going to be activated when the data which is in MDR register is transferred to the memory bus data lines. Okay, during memory read and write operation, the timing of internal processor operations must be coordinated with the response of the addressed device on the memory bus. The processor complete one internal data transfer in one clock cycle. The processor will complete one internal data transfer. Either it may be read or write a data transfer in one clock cycle. The speed of operation of the addressed device, on the other hand, varies with the devices. And also the modern processors include a cache memory on the same chip as the processor. So typically a cache will respond to a memory read request in one clock cycle. However, when a cache miss occurs, Okay, means the data which we want or the address which we want, which is not present in the cache memory, that is a cache miss. So whenever a cache miss occurs, the request is forwarded to the main memory, which introduces a delay of several clock cycles. Okay, so because of cache miss, we are requesting that we are forwarding request to the main memory. It includes the delay of several clock cycles. A read or write request may also be intended for a register in a memory mapped IO devices. Such as IO registers are not cached, so their access always takes a number of clock cycles. So input output registers are not be connected with the cache memory, so their accessing will take several clock cycles. In order to accommodate the variability in response time, the processor waits until it receives an indication that the requested read operation has been completed. Will we assume that a control signal called memory function complete MFC is used for this purpose. The addressed device set this signal to 1 to indicate that the content of the specified location have been read and are available on the data lines of the memory bus. Okay, so now look for an example, consider an instruction move R1 comma R2. Okay, so here we are transferring the data which is present in the address of the R1 register. See here R1 is the pointer. Pointer stores the address. Okay, so the address which is present in the R1. Okay, in that addressed data has to be transferred to the R2 register. Okay, means first we have to fetch the content of R1. In R1 we will have an address, and in second step we have to fetch that address. Okay, after fetching that address we have to transfer the data in that address is transferred to R2 register. Here move means data transferring operation will be occur. Okay, so the first step is what the processor will do. First it will send the address, means content of R1. Here R1 is a pointer, it stores the address. The address which is present in R1 register is transferred to memory address register. Okay, so in order to transfer the address within the R1 register to MER register, first we have to enable R1 out. So first we have to enable R1 out. Okay, so whenever R1 out is activated, the address which is in R1 is transferred to the processor internal bus. So from the processor internal bus, the data has to be transferred to the memory address register. So we have to activate memory address register in. So the first step is we have to transfer the address in R1 register to MER. This is our first step. And in second step, we have to start the read operation on the memory bus. We have to read the content which is present in that address. And next we have to wait for the memory function to be completed. After completing the memory function, we have to load the data which we read has to be loaded into the MDR register. from the memory bus. And next step, our destination, we have now the data which is presented in the MDR register. Now we have to transfer the data which is present in MDR register into R2 register. So this is the basic steps which we need to complete it. So all these actions may be carried out as separate steps, but some can be combined into a single step. Each action can be completed in one clock cycle except third step. Except the third step means wait for memory function complete, so which requires one or more clock cycles depending on the speed of the address device. For our simplicity, let us assume that the output of MAR register is enabled all the time. Thus, the content of MAR memory address register are always available on the address lines of the memory bus. Means memory address register output control signal is enabled every time, all the time, so that memory address register is always available on the address lines of the memory bus. This is the case when the processor is the bus master. When the new address is loaded into the MAR memory address register, it will appear on the bus at the beginning of the next clock cycle. Okay, at the beginning of the next clock cycle. So in our first we have to transfer the content of R1 register to the MAR by activating R1 out control signal. Whenever we activate R1 out, the address or the data which is present in R1 register is transferred to the MAR by activating MAR in control signal. Okay, so first we have to activate the R1 out, then the data which is present in R1 is transferred to the processor internal bus, and next we have to activate the MAR in control signal. The address which is present in processor internal bus is transferred to the MAR in. Okay, so next we have to wait for the read operation, means it is a read operation. Okay, means the memory has to fetch the address and it has to send the data, so we have to wait for memory function to be completed. After memory function is completed, we have to enable MDR in external. By activating memory data register in external control signal, the data which is present in the memory data line is transferred or is going to be stored in the MDR register. Okay, so by activating MDR in external, the data which is present in the memory data line is transferred to the MDR and it is stored in the MDR register. So after that we have to transfer that data to the processor internal bus by activating MDR out control signal. Okay, so after activating MDR in external control signal, we have to activate the MDR out. So the data which is stored in the MDR is transferred to the processor internal bus. So now we have to transfer that data from processor internal bus to the our destination register R2. So we have to activate the R2 in. When we activate the R2 in, the data which is present in the processor internal bus is transferred to the R2 register. Okay, so this is the our operation. So first we fetch the address of, means the content of R1 by sending that address to the MAR to the memory bus. So memory will find out that address and that data has to be sent to the MDR. From MDR, the data is transferred to the R2 register by activating proper control signals. Okay, so now we will see the timing diagram. Whenever a new address is loaded into the MAR, it will appear on the memory bus at the beginning of next clock pulse. Okay, at the beginning of the next clock pulse. A read control signal. Okay, so a read, so this is the read control signal. A read control signal is activated at the same time of the MAR is loaded. Okay, see, so the read cycle is activated at the same time or at the same clock pulse of the MAR is loaded. The signal will cause the bus interface circuit to send a read command. Okay, in order to send a read command. And next, the memory register on the bus. It sends a read command to the memory read on the bus. With this arrangement, okay, so with this we have completed, so first 2 steps. Okay, and next third and fourth step. Third and fourth steps are going to be combined by activating the control signal MDR in E. Okay, so the third and fourth step. The third step is we have to wait for memory function complete, and the fourth step is we have to load the data into the MDR register. So these two are going to be combined by activating the control signal a memory data register in external in next clock pulse. While waiting for a response from the memory, the data received from the memory are loaded into the MDR. The data has to be loaded into the MDR at the end of the clock cycle, in which memory function complete signal is received. See, so the MDR register is going to be loaded with the data at the end of the memory function is here. The memory function is completed in the third clock pulse. Okay, so after completing the memory function, the data register is going to be loaded with the data. In the next clock cycle, MDR out is activated. Okay, so in order to transfer the data to the R2 register here. Sorry, in previous one, here the MDR is going to be loaded. So after it is loaded with the data, the memory function is completed. Whenever the memory function is completed, the MDR out is enabled. Okay, so here in the last clock pulse, third clock pulse, MDR out is enabled. So okay, so in order to transfer the data from MDR to the R2 register. This means here the memory read operation requires mainly 3 steps. Okay, so already I have discussed these 3 steps. Okay, so where the memory function complete is the control signal that causes the processor to control the circuitry to wait for the arrival of a memory function complete. After memory function is completed, after completing the memory function, then only the data has to be loaded into the MDR bus, and then from MDR2 the data is transferred to the R2 register. And also see here, whenever MDR is here, the memory data register in external is set to 1 for exactly the same period as the read command and memory register are going to be activated. Whenever these read and memory read operation are set, automatically MDR in external will be set to 1. Okay, so this is how the data is, or the a word of data is fetched from the memory. Okay, so how the processor will get the data from the memory. Okay, and in next we have to know how the data is going to be stored in the memory, means how the data is transferred from processor to the memory and how that data is going to be stored. Writing a word into a memory location follows a similar procedure, same as fetching a word from the memory. This desired address is loaded into MAR. Then the data to be written or loaded into MDR, memory data register, and a write command is issued. During fetching a word, read operation is performed. During storing a word into the memory, here write operation is performed. Here the processor has to send both address and the data. Okay, so the data in which address the data has to be stored. Both the information, both address and data are sent by the processor in case of storing a word into the memory. In case of fetching, the processor will send only address from MAR to the memory. Here storing means the processor will send both the desired address and the data which has to be loaded into the MDR. Both are sent by the processor. So this is a write command, or it is a write operation. So for example, consider an instruction move R2 comma R1. Okay, so it follows these following 3 steps. So first what we have to do, first we have to activate R1 out, so that the address which is present in R1 register is transferred to the processor internal bus. After that we have to activate MER in control signal, so that the address in the processor internal bus is transferred to the MAR. Okay, so after that we are activating the R2 out, means in this R2 out we have the data. Okay, so whenever we activated the R2 out control signal, the data which is present in R2 register is transferred to the processor internal bus. And next we have to activate the MDR in control signal, so that the data in processor internal bus is transferred to the MDR. So here a write operation is going to be performed. Okay, by using MAR we transferred the address. Okay, by using MDR the processor transferred the data. And next And next we have to, for transferring the data to the processor internal, for transferring the data in the MDR to the memory bus, we have to activate the MDR out external. By activating MDR out external, we will transfer the data which is present in MDR register to memory bus. After that we have to wait for memory function complete. What here memory will do? First memory will find out the address which is sended by the MAR. After finding that address, the memory will store the data which is sended by the MDR register. As in this case of the read operation, the write control signal causes the memory bus interface hardware to issue a write command on the memory bus. Okay, and next the processor will remains in step 3 until the memory operation is completed and MFC, memory function complete response is received. So the processor will be wait until it receives the memory function completed response. Okay, so this is how the data is stored into the memory. In order to fetching the data from the memory, the processor will sense only the address. In case of storing a word into the memory, in this case the processor sends both the data and the address in which that data is going to be stored. So both are sent by the processor. Here memory will fetch the address and it will store the data which is present in MDR register into that particular specified address. Okay, so in next lecture we will discuss the execution of a complete instruction. Okay, how these instructions are going to be executed step by step we will learn in next lecture. Okay, thank you.